Welcome back, Gangies. We're back once again. The sickness that we were coming down with has passed moderately. So, as you can see, the voice pitch is slowly returning to normal, but our brain pitch may never return to normal. We were born this way. Something's wrong. So, hopefully, they can tell us something at the doctors. But yeah, that's kind of where we're at. So we're doing some mediums. Every medium we've tried so far, we finished on the first try. It remains to be seen if that is the case. However, things must be done, and yeah, that's kind of how it be. Uh, so yeah, I'm definitely maybe it hasn't passed. Maybe it hasn't passed. I might be celebrating too early. We shall see. I'm feeling a little bit better so far, but who knows? Honestly, we could be dead later. So that being the case, that's kind of where we're at. We're gonna do another medium today. Hopefully, we can do it. Some of these problems are worded like cryptic, or uh, like cryptic. Yeah, just these really cryptic letters from 200 years ago. I'm not sure why they're written that way. Maybe it's on purpose. Either way, it's kind of the worst thing to ever happen. That being the case, somehow we must prevail, right? We haven't been. I would say we haven't been reading the last 4 days. I mean, we usually read every day in Sienna's book. I'm pretty sure I've read the book twice now, and I still don't understand it. But a little bit, I understand a little bit more now. But yeah, I think that's where we're at. I haven't read that book in like 3 or 4 days, so I'm probably gonna start reading it again soon. But yeah, I think I gotta reduce the number of things I'm focusing on. There's just too many things. I have a lot of tasks that I try to do every day, and some of them are very simple, but they all take just the same. They all have different amounts of length and difficulty. For example, I'm not going to say them, but they all have different amounts of lengths and difficulties, but they all take the same unit of spoons, or maybe not spoons, of brain sauce. So 1 liter of brain sauce, even if it's something really, really simple, takes about 1 liter of brain sauce or executive function just to start the thing. So even no matter how simple a task is, it always chips away at the bucket, which is kind of annoying. But I think our base brain sauce capacity is increasing. So maybe that's a good thing, but maybe it's not. I mean, I've read a little bit of literature on this, and it seems to be completely nonsensical. It seems to really depend. I think the study that I read or something like that said if you have an allotted amount of time or capacity to focus or employ like these sorts of executive function things, then it's true. But if you don't believe you have a limit, then you also don't have a limit. It seems to be whatever you believe. And I'm inclined to think that whatever you believe is probably deeper rooted, so maybe it's just hard to change. I'm definitely of the body of mind that there's a capacity, and I definitely operate under that. And maybe that's why it's a mindset thing. If I think I'm out of capacity, then I'm less likely to try. Then I'm less likely to succeed, which is kind of like a self-reinforcing thing. If I believe I have no limit, I'm probably more likely to try, more likely to succeed, and it's probably the same reinforcing thing. So that being the case, we're definitely in the latter or the former bucket. I don't even know which one, but the bucket where we think we have a capacity. So hopefully things get better, but we shall see. That being the case, I think we're going to jump into some meetings. We're a little bit strapped for time. So yeah, so I'm going to jump into it. Make sure to join the Hyperbolic Coding Chamber Discord. I'm definitely feeling better about doing mediums. So far, we've been pretty successful. It's going to get crazy soon, though. But each problem so far has had a nice little bit of difficulty, which has been nice. So I think that doing all the easies definitely allowed us to practice getting into form a lot. So it feels easier to not get lost in bodies of text. I don't know how to explain it, but repetition is truly repetition is truly magical. So hopefully with more repetition of medium problems, we'll be unstoppable. But only time will tell, and this experiment will hopefully have some nice results. So I'm going to jump into it Today we're doing container with maximum water, which sounds a lot like a DP problem, which also sounds a lot like trapping rainwater. So we'll see. I'm going to start the timer. We have 30 minutes, so we are given an integer array height of length n. There are n vertical lines drawn such that two endpoints, n vertical lines drawn such that the two endpoints of the ith line are I, 0. Oh, right. So the x point, I think they mean the two x points are I, 0 and I, height sub I. Find two lines that together with the y-axis form a container, such that the container contains the most water. This sounds a lot like trapping rainwater. Notice that you may not slant the container. Okay, that's crazy. So we have height, right? This array of integers, and we need to find the largest amount of water we can contain. And it's definitely clear as to why this is. It looks like you can also go through the walls, which is an important distinction to make. The real question is why, how did they get 49, right? We know that we're working with the second integer, the second column drawn, which is 8, and the last column drawn, which is 7. Is it the difference between the lowest height container? Maybe it is. So we'll have 7 minus 6 gives us 7 minus 6. I'll just copy this. Copy the values here. I wish we had some more Vim foo, then we could separate it better. But 7 minus 6 gives us 1. 7 minus 2 gives us 5. 7 minus 5 gives us 2. 7 minus 4 gives us 3. Yeah, there's no way this adds up to 48. What if we just add the numbers in the columns up? 6 plus 2 is 10. Plus 5 is 15. Plus 4 is 19. Plus 8 is 26. Yet the value of the height of the above vertical lines represented by the array. Blue section the container can contain is 49. Clearly we're not onto something here, so let's do some more thinking. The above vertical lines are represented by array 1, 8, 6, 2, 5, 4, 8, 3, 7. The max area of water. Oh, the area of water. Oh, the area. Right, the largest container we can create. They mean the largest rectangle. If that's the case, I'm pretty sure you could do this in n squared time. Because at the end of the day, the reason it's 49 is because of the two boundaries, we have 8 and 7, but the max that we can store is the minimum of the two boundaries, which would be 7. 7 times 7 equals 49. If that's the case, I think we can do this in n squared time, right? Since we're always going to be taking the min of the two, right? We almost don't even need Well, let's test something actually. If we have something like this, let's just add a new test case, right? We need to see if the area thing is true. If we add a bunch of 1s, then I add 2 7s right next to each other, will the maximum container that's able to create, will the maximum area still be 49? And then I'm just going to return 0, so it gives me what the actual answer is supposed to be. So it expects 7. Now that's strange. What if we add a 1? What if we had, are we saying we need to have at least 1 separating them? At least 1 value separating them. It's true. So it looks like we have to have at least one degree of separation. Right, so I'm thinking we could do this in n squared time for each number, right? We're gonna make sure that the number, for the current number that we're on and for every other bar in the graph, we're gonna see what's the largest container we can make. And so we're going to multiply those, going to be the math.min of the 2 times 2, right? If they're the same, then we'll be fine. If one is larger than the other, then we'll get the actual smallest container we can create. And I feel pretty good about that. My worry is that, is it going to be reflective or reflexive? If we have 1 7 here, right, the minimum max container we can make is going to be 1 by 1 anyway. Even if you reverse it, you still get the same value. So I'm thinking that this should work. For let I is equal to 0, I is less than height I plus plus. Now what if, right, we definitely don't want to use I, but we'll use J since it seems to be our next go-to. We'll take J and we do, multiply the value, right? We'll be multiplying the value. The above vertical lines are represented by array 186254837. I was I, j is equal to j is less than height dot length, j plus plus. Should I be equal to j? I mean, I think we pretty much only ever want to check, so you only want to check one forward, right? There has to be at least 1 degree of difference so that area can even exist. And then we'll just say that we'll just say area equals 0. We'll return area. Here we'll say area is equal to the math.max of area, or the math.min of height sub I, or height sub j to the second power. You're wrong. Hmm. Actually, now that I'm thinking about it, why isn't the maximum area 8 and 8? Why isn't this equal to 8? Hmm. Let me reread the problem. Given an integer array height of length n, there are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I. Two endpoints of the ith line, I, 0 and I, height sub I. Find two lines that together with the x-axis form a container such that the container contains the most water. Then the maximum amount of water a container can store. Wait a second. I think I'm seeing why. It's the area, and we're not supposed to use both heights. We're supposed to use the distance. So it's not squared, it's multiplied, right? Because this is 49 because the height, or the minimum of the two heights is 7, but the distance, 1, 2, 3, 4, 5, 6, 7, it's 7 away. So it should actually be the min of these two heights times j minus I. Well, let me just double check that real quick. We'd have 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 8. Yeah, 7. 0, 1, 2, 3, 4, 5, 6. 6, 0, 1 is 5. 8 times 5. 8 times 5 gives you 4. Yeah, 8 times 5 gives you 40. Where are we getting 55? Where are we getting 55? Where do we get 55? We have 1, 8, 6, 2, 5, 4, 8, 37. Oh. I think we just need order of operations. Which is a little silly. Yeah, okay. So this actually is looking not too bad so far. And the second thing is when there's when there is no when the length of the array we'll also just keep track of max height. It's going to be the math.max of max height. And height sub I. Right? And we'll say if height.length equals 2, right? We want to return max height because we can't calculate an area. Right? Otherwise, we want to return the calculated area. Output is 4. This doesn't make any sense. Oh, it wouldn't be the max, it would be the min. Even then, though, something's wrong. Because we are passing the case with 1, 1 already. And this actually makes us fail it. They're saying here that the max height, oh, it should have been 14. So it looks like what we're looking for is 7 and 7. So why aren't we, well, we should be getting that. Huh? Apparently we're only doing 1, 0. What am I printing here? I'm printing Y. Oh. How did J minus 1? Oh, okay. Something is just, okay. Yeah, I'm not, I think we just made some typing errors or something. I'm not certain. I'm not convinced this will work though. It feels like we're missing something. Or maybe it's too slow. Maybe only linear time is acceptable. Yeah, it does look like it's a little too slow. It looks like our solution is good enough. How can we roll this up? They definitely want us to do some DP nonsense. Feels like it's n squared no matter how you look at it. Can we roll this up? What if we do a two-pointer approach? We have a pointer at the front and a pointer at the end. A PTR at the front and a PTR at the end. How can we roll this up? Maybe there's a simpleness to this, though. If we cut this thing in half, isn't the maximum container always going to be the leftmost largest container? In the rightmost smallest container? You want the tallest leftmost rightmost. You want the tallest leftmost bar and the tallest rightmost bar. Looks like we need a linear time solution. We haven't considered DP yet. I'm still trying to figure out if there's a way we can do this with simple heuristics, but yeah. I think we'll be back tomorrow to try more on this.